Hey guys, welcome back. Today we're going to continue our series on Cracking the Coding Interview, the #1 software book for software programmers, recommended by all top companies in the world. Today we're going to be solving a problem, chapter 1, called Rotate Matrix. Feel free to pause the video just to read through what this problem is actually asking for. However, I find using examples more descriptive. Okay, so given an n by n matrix, we want to rotate it 90 degrees and we want to try to do it in place. So here's how we're going to approach this problem. Let's kind of see how we're going to try to approach this problem. This is a red line. So say we were given a matrix. I'm just gonna say math equals, we were given 3 by 3 matrix, 1 2 3 4 5 6 7 8 9. We want to rotate him, and to rotate it doesn't specify what rotation, so let's do a counterclockwise rotation, CCW, counterclockwise by 90 degrees. Okay, it just says rotate by 90 degrees, doesn't specify counterclockwise or counterclockwise. So let's start with counterclockwise. So rotating this guy counterclockwise just means taking this guy and moving him count this way. So it's gonna look something like this. It's gonna look 3 6 9 2 5 8 1 4 7. This is what a 90-degree counterclockwise rotation will look like. This is what we're trying to get. We're trying to go from math to this, and this is done in, we can do this in a 2-step process. Okay, first step, let's start with step 1, is reverse the roles. So starting with math, starting with this guy right here, we now want to reverse his roles. So this is what it's going to look like after we're done reversing the roles of math. So this is going to be a 3, let's reverse the first row, 2 1, let's reverse the second row. This is going to be a 6 5 4, let's reverse the third row. This is going to be a 9 8 7. This is what reversing it does. And just so this is clear, I'm going to write the indices. So this is index 0, index 1, index 2. This is index 0, index 1, index 2. So I hope this is clear so far. I'm going to write my 2 better. So that's the first step. Now the second step, which happens to be the actual algorithm where the meat and potatoes happen, is we're going to have to iterate through this newly reversed rows of matrix. So say something like a for loop, say for I going from 0 to obviously the length of this matrix. That's the first for loop. We're gonna do a nested for loop. We're gonna have a second for j. J is gonna go from 0, but he's not gonna go the length. So I is going from 0 to the length of the rows, right? J is not gonna go the length of the column. He's just gonna go up to I. That's all he's gonna do, go up to I. And now once we do this, we're gonna have our actual algorithm, which is pretty much, we're just gonna swap matrix of ij with matrix of ji. Already swap those two positions, and that's it. We are done with this algorithm. So let me show you guys what that looks like. Okay, let's start with the first iteration. First, we're gonna be on index I equals 0, j equals 0. In this situation, guess what happens? So we're on this guy right here, 3. We want to swap. If we try to swap math of 0 0 with math of 0 0, it's literally redundant, right? It's useless. So we can literally iterate from j to I minus 1, not just j, because we can swap the same with the same. It's just gonna stay 3. So we're just gonna leave it alone. So I'm gonna say in this instance nothing happens. Then we're gonna move on. So since j only goes up to I, that's the end of this loop. So next we're gonna go to I equals 1, j equals 0. Now the same thing we're gonna do, we're gonna try to swap. Let's swap math of ij. So I happens to be I is 1, j is 0, with math of 0 1. Let's see what is 1 0. 1 0 happens to be 6. Okay, so we want to swap 6 with 0. 1 0 happens to be 6. 0 1 happens to be 2. So we want to swap 6 with 2. Okay, so let's go ahead and do it. I'm going to write this in green so we know we swapped them. So we're swapping 6 and 2. So 6 goes here and 2 goes here. So we're done with this iteration of the loop. We're going to go on to the next one. I'm just going to draw a line here so we can have our solution on the same page. So in the next one, I is going to be equal to 1. J is going to be equal to 1, because remember j kind of goes up to I, but we've decided j can go up to I minus 1, because in diagonals we do nothing. When I equals j, there's nothing to do, but I'm going to show you guys. So here we want to swap, okay, matrix of 1 1 with matrix of 1 1. Again, this is redundant. 1 1 equal each other, nothing happened. Then we're going to move on. Okay, in this next iteration we're going to be at I equals 2, because remember j only counts up to I, and j is going to be starting back at 0. Now here the task is to swap matrix of 2 0 with matrix of 0 2. Let's find 2 0. 2 0 happens to be 9. 0, 2 happens to be 1. So we want to swap 9 and 1. So I'm going to go ahead and swap 9 and 1 in this case. Write them in green. So 9 goes here and 1 goes here. So that's it for this iteration. We're going to go on to the next one. So I equals 2, j equals 1. Math of 2, 1 with math of 1, 2. So let's find who our matrix of 2, 1 is. Who is 2? 2, 1, that happens to be 8, and 1, 2 happens to be 4. So we want to swap 8 and 4. So always let's write the guys we swapped in the green. So 4 goes right here and 8 goes right here. And now finally we're going to get to the last iteration. I equals 2, j equals 2. We've already established that 2, 2 is a diagonal. We can't swap math of 2, 2 with math of 2, 2 because nothing happens, so nothing happens here. So that's it. We're pretty much done with our algorithm. And you can see that this matrix right here equals this matrix rotated counterclockwise. But now one last question is, what if we wanted to rotate it clockwise? It's pretty much the same steps, it's just that we have to do for clockwise. We're going to have to do step 2 first, then step 1, but everything else is the same. In this case we did step 1 first, which was reversing, then step 2, which is just swapping. For clockwise we're going to have to do the swapping first, step 2, and then after the swap, reverse. Without further ado, let's put the solution to code so you guys can see how it works. So let's define our function. I'm going to call it rotate. Let's call it rotate counterclockwise. Okay, let's go ahead and we're going to take in a matrix called math. For now, let's say pass. And let's go on and edit our driver code. To edit our driver code, let's define our matrix math. I can't type today. So math is going to be equal to our matrix. Remember we had 1, 2, 3, 4, 5, 6, 7, 8, 9. Now let's go ahead and first let's print this math. But also let's go ahead and call our function. Okay, as always we like to run it first just to make sure there's no obvious errors. Okay, it prints math and returns none. Perfect, just like we wanted. So first step, like I said, is a 2-step process for counterclockwise rotation. First step is to reverse it. So for I in range length, so we're iterating through the rules of the matrix. Now we want to reverse it. So I'm just going to say math of I. Okay, this is some list of string manipulation going on here. Equals math of I. Okay, the same rule, but give it to me reversed. So in Python we can reverse it like this. That's it, we're done with reversing it. Python makes it so easy to reverse. So now let's start swiping. So for I in range, again this I here is different than this I, is different scope. I'm just choosing to use I, but you can use whatever you want to use here. Length of math. So I'm iterating through the rows of the matrix. Now for j in range, like we said, j is just gonna go up to I. Okay, actually I minus 1. Keep in mind in Python the range operator is exclusive of the upper bound, right? So she's just gonna go up to I minus 1 because in the diagonals we do nothing. Now what do I want to do? I just want to swap it. So I'm just gonna say map I j, map j I. This is why I love Python. It's just equal to. We can do this in all in one line. So now I'm saying math ij equals math ji, and now math ji is just going to be equal to math ij. Then in the end we're just going to return math. So we're expecting this. We're expecting this matrix. Let's zoom in a little bit more so it's clearer. We're expecting this, right? So let's run it. Oh, I said math, not math. So let's fix that. It's been a long day. Exactly. So we got 369, 258 correct, and 147 correct. Okay, in this input. So now we said this is a counterclockwise 90-degree rotation. How about we do a clockwise? So I'm just gonna create a second function. Say rotate. I'm just gonna copy this because I'm lazy. So rotate, and we want to do clockwise, not counterclockwise this time. Okay, and we said to do it clockwise is the same as counterclockwise. We just have to do step 2 first, which is swapping, and then once we're done swapping, okay, before you return, obviously, let's go ahead and do step 1, rotate it. Okay, so we did the swap first and we did the rotation, right? So let's go ahead and run this, but we're gonna have to redefine math before we call the function the second time, because this return statement in the first function is gonna return the already rotated version and we're gonna swap it. If that makes sense, it's gonna make it like messy, but you'll see what I mean in a second. Okay, but we want to call it for rotated math. Okay, done. So this is our original matrix, this is our counterclockwise rotation, this is our clockwise rotation of this original matrix. That's the reason why we had to redefine math here, because if we didn't, we're going to end up rotating clockwise this already counterclockwise rotation. Actually, that might be a good experiment, because if we counterclockwise rotate this matrix by 90 degrees and then we clockwise rotating by 90 degrees, we should get our original back. So let's try it. Let's comment out this definition and see what happens. Bam, exactly. So this is the first function call where we counterclockwise rotate him by 90 degrees, and this is the second one where we clockwise rotate the output of this function 90 degrees. So that's it for the video, guys. I hope it was helpful in showing you guys how to do this problem, and I'll see you in the next one.